everyone. My name is Tebo. I'm originally from Mongolia, born and raised there, and also lived in Chicago for a good amount of my life. I'm an I.S.E. student majoring in mechanical engineering, and I started this project with Ethan and Isaiah in beginning of January, working on this scanner automation / mount CAD design project.
Yeah, and I'm Ethan Carpenter. I'm like Tebo was saying, I'm an NIC student going for mechanical engineering, hopefully to progress to a aerospace minor. That'd be awesome. Yeah, just working through the courses and started the project at the same time.
Cool. Yeah, I'm Isaiah Preston. Also going for aerospace, doing mechanical engineering right now because that's a little bit cleaner path for bachelor's. Hoping to get aerospace master's and move on to work for some aerospace companies, NASA, astronautics, that kind of stuff. I'm from New York, but I've lived in Idaho since I was like 6, so I like to say I'm from here. We are A.R.I.S.E, which stands for
Aerospace, Robotics, Imaging, and Scanning through Engineering.
Yes, yeah. So currently working with a standard bot, so like a big robot arm, and we're trying to utilize that to automate a process that some aerospace manufacturing companies have right now, which is using a scanner that looks like this to like check parts for defects, and we're trying to automate the process because it's done by hand and it's very tedious and laborious and expensive to get that done. So if we can create a program that runs through that path with some kind of attachment to the scanner, then we can automate it and make it a lot cheaper for the company. We ran some calculations on different stresses that different parts would feel, a lot of 3D modeling, so that's what all of these are, different designs, and this is kind of the idea we're at right now. So something with this like quick dry putty that becomes a rubber material. This gripper used to be able to open and close. We're dealing with an issue right now with the connector. So we designed it around the gripper being able to open and close, and it would close around the handle of the scanner, and then this affixes to like a big armed standard bot that can move around and scan the different parts. So either gonna fix that current issue or make a slight adjustment, kind of similar to what Tebo's working on, to be able to not deal with this gripper and just fix it right to the robot arm.
Yeah, like Ethan said, our project mainly consists of 2 simple parts. CAD, which is this, obviously what we're doing, the gripper and the mount part. This is the design that I came up with, consists of 3 grippers separated. It's mounted here, it may be a little bit difficult to look, but straight up screw drive through the hose and just put on the standard bot. And then the second part would be our standard procedure for coding the standard bot with our resources for scanning workflows and comfortable movement.
So with Isaiah and I's design, he kind of touched on the moldable putty in here. That was made so we don't have to get because the geometry of the actual scanner handle is weird, smooth patterns that are pretty difficult to model around to make a gripper that fits directly to it. And so like Tebo used the foam there, we came up with this putty that you put in there, and then it dries to be a compressible rubber, so we don't have to conform to the geometry of the handle. We can just have a piece that it does come off to reveal like whatever. He has a different design on his for securing it on there. So this one's like a hex clad pattern with support beams, and it comes right off, and it's rubber. So it dries and it compresses, and it's just, it works.
Yeah, some of the benefits of this project is reducing like human error, reducing the time to scan, reducing the cost, like solidifying the repeatability of the scanning. But we're not sure what the size of the part's going to be or what the required scanning path is for the company. So we're still waiting on hearing a couple things. But what we do know is how we're going to fix it to the robot. So we've been working a lot on that.
Working a lot on that. So this is one of our designs that features 2 little receptors, if you will, that bolt directly to this third-party manufactured gripper that you can control through the standard bot. And then these 2 fingers is what we've been calling them, just attach right to it and bolt in, and then they have this, it's called Protoputty, this rubber design. It was a silicone caulking and cornstarch actually at a certain mixture that turns into like a Play-Doh-esque putty. You can press into it and then mold around the actual gripper, and that is able to conform to the handle geometry, so we don't have to spend hours and time and money modeling the actual design to be that. That would also introduce a constraint for the future work, which would be CNC milling this out so we can have an actual metal reproducible thing. A cool thing about this is we've kind of been going back and forth with how to affix it to the Protoputty to the gripper itself, and we've come up with like this hex clad pattern with mine is a couple supports in there to allow, you know, slippage or reduce slippage with the Protoputty when the scanner's attached, because it's like I think it's a 3.5 pound scanner, and it would be really bad if that just plummeted to the ground because of an error.
Yeah, so taking extra precautions to make absolutely sure that it's being held up.
For sure.
And our next step is actually testing the current designs to make sure that, you know, we can actually accurately test how much the scanner shakes in the movement of the standard bot with our design attachments to make sure that there's no shaking, it's not going to slip out, all that stuff's fully secure.
I think the biggest constraint currently is the unknown of our part size, because the parts that they're going to be scanning are anywhere from my understanding, like 5 feet to 15 feet long and a certain depth and height.
Yeah.
And so one of our biggest constraints with the scanning process is that aspect, because the robot only reaches like, I think 4 feet out before it starts to lose its center of gravity, starts to tip, and that's not good. So it has to, we have to get clarity on that in order to kind of
hear from ATC about how they actually want us to path the different scanning process. So
yeah, whether we're going to mount it, like we've talked about a ceiling mounted idea that might be able to reach more, or the robot mounted on rails so it can travel itself, which would add another layer of complexity to this whole project as well, because then we'd have to design and code that part.
Right.
Yeah, I think that's probably one of the biggest problems we run into. I think we all work pretty well together, so if we have like a design issue that we're not working through, it's nice to be on a collaborative team so we can kind of work through that and help each other in that aspect. So I feel like that's the biggest constraint, that physical constraint for sure.
Yeah, I think it's good to say we all started around the same time. In January, we mainly focused on getting comfortable with our Python programming system, and then we transitioned into our CAD part, which is we're almost done, and we'll be ready for the expo in week and a half.
Yeah,
ish. So we're almost done with the CAD, and up in terms of date wise, we're not 100% sure, but it is confirmed till June 30th is our confirmed deadline.
Yeah.
And we're having to plan it and get it ready by then, and both the CAD part and the processing programming part.
Yeah, but there's also other opportunities. So I know I submitted for a continuation for this project through a different type of, through the Idaho Space Grant Consortium through NASA. I submitted this project to go through there. So
continue funding.
Yeah, so if I get continual funding, then I would continue this project throughout the whole summer and kind of work into the future work. Like we want to end up having a couple or one of our designs being milled out on a CNC machine, so we don't have a plastic piece holding up $1,000 part. Yeah. So I think that'll be that's a big thing.
So a lot of it is just we're kind of, I think, a week or two out from knowing really for sure when our final date's going to be, but we're waiting on a couple. Like I'm also applying to a funding continuation, so we're kind of gauging it right now. Like we don't know what the programming path's going to be, so we're just doing what we know, and then as we find out kind of where that deadline is, we're going to start to hone in on like what's the actual cutoff time and plan for that.
We're actually working under the Center for Intelligent Industrial Robotics. which is typically a pretty computer science heavy department, and we're all mechanical engineering students. So it's cool to see the adaptability that the University of Idaho has provided, so we can all kind of work on this project together through a separate entity. And I thought that's a very cool on their part to allow that to happen.
This project has been a great opportunity to increase in innovation and improvements in real industry, and we are so thankful to University of Idaho, ATC, everyone involved for giving us this opportunity to learn and grow. And I just hope that I can keep improving and increasing these benefits to the real world.
Yeah, we're very thankful to the University of Idaho and ATC and everybody involved to support us in this project. I think we all kind of feel the same about how we're very grateful for this project and the funding, because this is kind of an insight in our college career about what we want to do for our career itself. Like, this is a very applicable opportunity, an internship that kind of shows us, hey, this is something we want to do. So this has just kind of been an eye-opening experience that we're very grateful for. Go Vandals. So, Project A.R.I.S.E, we will be at the Undergrad Research Symposium held at U of I, April 27th. Come see us. That'd be great. Talk about our project.
Yep.